Today, let us see the sensitivity analysis in a fractional distillation column to separate binary system. I think you are able to see the Dwsim window. I'm opening a new window. So I'll just go through how it works like so that you can find out what are the steps here. My voice may not be that essential, so you can actually work out as I do as I take up the steps in this particular activity. I have added acetone and water to be as a system. Now the next one is because there is a water compound, I am selecting NRTL to be as the equation of state or thermodynamic package, and I choose VLE phase equilibrium calculations. And for the next system of units, I select C5, wherein I can change the values here. I'm keeping temperature to be as centigrade and pressure, let us change it to atmosphere for our convenience sake. Others remain same. This is mass flow rate, molar flow rate, kilomoles per hour. Volumetric flow rate is also given. In volumetric flow rate, I will try to keep it in liters per hour if it is allowed. So I am taking liters per hour. Rest all I can say it is done. So I finished. First I go to the columns and then I get the shortcut column. Okay. Then go to the feed, 25 degrees centigrade. Pressure is 1 atmosphere. I convert it into liters. I give liters to be as suppose say 500 liters per hour. It is already taking the values here. Then I come to distillation column. The light key component is acetone. Heavy key is water. Reflex ratio, let us keep it as 3. Yeah. So I think the column has started running. We'll get the minimum results from the column. So let us go to the results section here. Yeah. So this is the results section. So what is important to us in this particular area is that whenever I try to do some exercise here, in it specifically distillation column. So what is the system we have taken? Acetone and water. This is the binary system. The thermodynamic model is taken as NRTL, and my feed we have taken it as 500 liters per hour. By default, the feed would have been at 50%, so 0.5, that means 50%. My interest is to know what are the number of stages. It has given number of stages to be as 5.04. So approximately 6 stages would be there. And the actual feed stage has been given. So NFT is known. It is around 2.52. So 3, approximately 3. Sorry, approximately 3. And our interest is to know that in the condenser, what is the heat duty? In the reboiler, What is the reboiler? Steam. Here we supply steam, here we remove steam. So you have to say that condensativity is positive or reboilativity is positive. Both you need to explain properly. So now we are ready with what you call a column with certain operations. Okay. So let us actually see again what is the specifications what we have given in this column. So you can see the specifications in the column. So if I go up, so these are the specifications of the column. Light key mole fraction, heavy key mole fraction in the distillate. Light key mole fraction in the bottoms means acetone is our light key. So in the bottoms, I'm intending to obtain 0.01. That means in the top, it should be 99%. Whether it is possible or not, whether it has been possible or not, we need to check. And you can see the condenser pressure 0.796. It has taken to be as 0.796 for the specification which we have fixed. Okay. Let us see the outlet here. So this is the outlet. You should be careful in the selecting the streams, which is blue color, which is red color. Okay. Now you can see the temperature at the top. Temperature at the top, we have not fixed anything, but it has taken it directly. So compound amounts, you can see acetone, how much is coming? 99%. So results, you can see the results, right? In the feed, as I've said, as I've told you, I have not mentioned anything about the feed, right? But my intention is to take 500 liters per hour. For the 500 liters per hour, how many kgs per hour, how many kilomoles per hour it is calculated. And if you come down, there are certain, and vapor phase mole fraction is 0. That is what is selected here. That means there is the total completely, it is a liquid. The compound amounts by default is 50 and 50. So for this, what are the QB and QC? You need to actually look at the situation. Now, if I go to this acetone, if I say it is 0.55 now, okay, and obviously this should be 0.45. Water should be 0.45. Now, I normalize and then I again try to solve the total problem. See, it is again is not taking, so it is not accepted thoroughly. So you should actually press accept also here 0.55. Yeah, so now it is accepted. To come down, go to the distillation column again, check again whether the feed composition is taken out. Yes, it has taken. Now click on the distillation column. Now reflex ratio is still 3. I want to now run the program with this particular distillation column. Now run the program and then check again the details. Now there will be again change. You can see the actual number of stages. Previously it was 5.04. Now if you can see it is not 5.04, it is 5.42. But still there are certain changes. That is what I am trying to say. There are certain changes in the results. So we are done with, and now you can see the condensativity and revolatility. What has happened here? Previously the results were different. Now the results are different. Okay. We'll go to the next video and check how to do the what you call with these particular results obtained. We will try to work on the sensitivity analysis.